Hi everyone, in this video we will discuss the substitution type problems for differentiation 1. Substitution type problems are special type of problems, again in which if you know the type of the problem you can solve it very quickly, otherwise it will take you a long time to solve problems and you will miss out on a very easy question just because you do not know the type of the problem. So substitution type problems have a prerequisite that you should be fluent in trigonometry. So I will recommend you that whenever you see problems of differentiation, if you have forgotten trigonometry, just remember the formulas again and again. If you just directly try to solve the problems without completely forgetting the trigonometric background, it will be very difficult for you. So revise the formulas, basic formulas of trigonometry of sine 2 theta, cos 2 theta and things like that, and that will be really helpful for you to do these problems. So what do we mean by substitution type problems? So basically we substitute some form of x as something else, and then that helps us solve the problem. So I will write down few substitutions here, so that will be handy for you when you are trying to solve the problems. For instance, if you can substitute it as x is equal to a sine theta. Whenever you see something like a square minus x square, you should try to substitute as x is equal to a sine theta or x is equal to a cos theta. Okay. If you see something like root of x square minus a square, then you should try to substitute something like x is equal to a sec theta or x is equal to a cosec theta. I hope this makes sense why we do that. We do this because whenever you will substitute x is equal to a sine theta or a cos theta, the square root of a square minus x square term will become a cos theta or a sine theta. So, and if you have x square minus a square, then it will become a tan theta or a cot theta if you substitute a sec theta and a cosec theta. Similarly, if you have root of x square plus a square, then you should naturally substitute x is equal to a tan theta or x is equal to a cot theta. This will basically make things very easy. So let us do an example problem so that you will get an idea of what do I mean by substitution problems and how you will solve them. So the question says tells us that y is equal to tan inverse of x by 1 plus root of 1 minus x square. Okay. Question tells us that this is now we have been asked to find dy by dx. So if I have to go this by the normal route, what I will do is I will say, okay, this is tan inverse of x type problem, so I will do 1 plus 1 by the whole thing square, right? Then I will take a differentiate this thing. To differentiate this, then I will do the division rule, and within the division rule I will have to differentiate root of 1 minus x square, which will require chain rule. So you can spend a lot of time on this and then you will arrive at the answer, but a very quick thing, and for this you need to remember trigonometry. If you don't remember trigonometry, then you will have problems in solving this thing. So one thing which you should spot very clearly is, can you convert this whole thing, can you somehow convert this expression, this part, into some type of tan theta? Can you like some type of tan theta or tan alpha or whatever? Can you express or can you spot that? And I mean, if you are familiar with trigonometry, then you can remember that there is something, and there is a root of 1 minus x square here and there is x here. So if I substitute x as sine theta or cos theta, then basically if I substitute as sine theta, this will become sine theta by 1 plus cos theta. And if you can remember this formula, if you do remember this formula, then it should be very easy for you to remember that sine theta by 1 plus cos theta is nothing but tan theta by 2. Basically how you get that is, this is 2 sine theta by 2 cos theta by 2 by cos square theta by 2. So this is nothing but tan theta by 2, right? So all you need to do is just substitute x as, so let us substitute x as sine theta, so that you will get something like this, right? If you substitute this, so then y will become y is equal to tan inverse of sine theta by 1 plus cos theta, and this is tan inverse of tan theta by 2, or the answer is theta by 2. Okay. So, or you can write this as y is equal to theta by 2. So, if you want to differentiate, all you need to do is you can call this theta as sine inverse of x by 2. So, if you want to differentiate dy by dx, you can just have to differentiate sine inverse of x, and that is just a formula that you already know, and multiply by half. So, that is your answer. So, now you could have spent a lot of time trying to solve this problem, and you wouldn't have reached much to anywhere, because this is straightforward trigonometry substitution, and these are the kind of problems you will get. It may not be just directly x is equal to sine theta type problem, but might be something else. But these are the kind of problems which you will get very often in JEE type problems. So, please practice some problems like these. Let me give you one more example so that you can make yourself familiar with these problems. So, that problem says is that y is tan inverse of a cos x minus b sin x by b cos x plus a sin x, and we have been asked to find dy by dx. So, now how do we approach a problem like this? There is no standard a square minus x square minus a square type substitution. So, what do we do in a problem like this? Again, trigonometry practice will help you a lot in this. So, very quickly what you can spot is that within the argument, again the idea should be to make something like tan theta so that you can simplify this. Something which is very critical for you to spot here is that in the numerator cos x is multiplied by a and sin x is multiplied by b, whereas in the denominator cos x is multiplied by b and sin x is multiplied by a. So, that means what you can quickly see is that if you want to make it a tan theta, then you should make numerator as sin theta and denominator as cos theta, and if you make it sin theta cos x minus cos theta sin x, so that will become sin x minus theta, and then automatically this will become cos theta cos x plus sin theta sin x, which will become cos x minus theta. So, that will become tan x minus theta or something of that, basically of that idea. So, that is the whole idea. So, it is not a standard substitution type problem, but you can still spot that if you want to make this a tan theta type thing, then you should substitute a as sin theta. You should make this term as a part as sin theta. So, this is a standard substitution which you should probably remember from a trigonometry, but you can again see the idea here. What you can do is you can substitute a by root of a square plus b square as sin theta and b by root of a square plus b square as cos theta, and if you substitute this, then you will get something like this: y is tan inverse of, and if you divide by root of a square plus b square on both numerator and denominator, that will get cancelled. So, you will at the end get sin theta cos x minus cos theta sin x by cos theta cos x minus sin theta sin x, and in other words, this is nothing but tan inverse of sin of theta minus x by cos of theta minus x, and this is tan inverse of tan of theta minus x, because this is what we wanted to do. We wanted to make it a tan, so then this will become theta minus x, and so y is theta minus x and dy by dx. So, y is theta minus x and theta minus x, and dy by dx is simply minus 1. So, this problem is again straightforward if you can remember trigonometry. So, just so that you do not get confused, this is The problem is here. I mean, this is again, if you can remember, spot quickly that you are trying to convert this to tan theta, you can leave the problem. Otherwise, if you think about this, if you go from first principles, like from the idea the way we do normal problems, if you do tan inverse differentiation, that will be 1 plus whole square of this, and then you have to differentiate this messy function, and that will take so much time for you to solve, and you might not even be able to simplify this, but you can very quickly simplify this to -1 if you can understand and appreciate how to do substitution type problems. So I gave you two ideas here. One is if you spot something like 1 minus x square, you can quickly substitute these functions, or x square minus a square or x square plus a square type things. You can do substitution and then convert it into something like this. Otherwise, you should try to do some intelligent substitutions of not of x functions but of something else, such that you are able to simplify it and make it very easy to solve. So I hope this helped you, and practice these substitution type problems, and in the next video we will talk about higher order derivatives. Thank you.